chapter that we will try to cover in today's class as a whole. To start this chapter, let me go back to the definition of random variable. We said there is something called random variable. We said something that changes unpredictably. Over time or over individuals or over one person to another person, over any space. If something is changing and changing unpredictably, that is called random variable. Then we said there are some discrete random variables and there are some continuous random variables. Whether they are discrete random variables or continuous random variables, the bottom line is every random variable has a probability distribution. Sometimes it is well known. Like binomial, Poisson, normal, Weibull, uniform.
Doctor, are you sharing your screen?
Yes, I'm sharing my screen. If you cannot see it, leave the session and join again. So sometimes the probability distribution is well known, like many we studied 4 or 5 in chapter 3 and 3 or 4 in chapter 4. And sometimes we said it is not well known. Like f of x is 2x minus 1 for x between 0 and 1.61803. So this is not something well known, but still the bottom line is if x is a random variable, it will have a probability distribution. Now I'm going to take you into an environment where I'm going to mix up your knowledge of this course and the knowledge of your lab course. And before I do that, if you have any question from the picture I just draw, where I said random variable is something that changes unpredictably, that's called random variable. We have some discrete, we have some continuous random variables. Every random variable has a probability distribution, sometimes well known, sometimes not well known. Well-known distributions you studied are like binomial, hypergeometric, Poisson, negative binomial, normal, Weibull, log normal, uniform, exponential. All of these are well-known distributions. And sometimes they are not well known, like 2x minus 1 is something that's not well known. But whether it is well known or it is not well known, the random variable will always follow a probability distribution. Now I'll take you to your lab course. In your lab course, you studied something which is called mean, the sample average. What do you do? In your lab, what you do is you have a population on random variable X. Maybe a finite population, maybe an infinite population. So you have a lot of values of X here, X1, X2, all the way up to Xn. And maybe finite, maybe infinite. From this population, there is a mean of X, which is denoted by mu. And this mean of X, which is denoted by mu, is a population parameter that is usually unknown. The question is, what do we do to estimate this mu? We take a sample from this population. We pick a sample from this population. That sample is X1, X2, all the way up to X small n, let us say. The size of this sample is small n. From this sample, what do? We calculate X bar, which is the sum of all values divided by the number of all values. We call this X bar as the sample mean. And we say that this sample mean is an estimate of, this is an estimator for this sample mean is an estimator for that population mean mu. That was the whole story we discussed in lab. We have a population on a variable. Let us say X. Let us say X is what? X is the, for example, score of students in STAT 319. Which students? All the past students, the current students, and the future students, all of them. So this is a sort of infinite population. So there must be an average score of students, which is unknown to all of us. To estimate that average score, what do? We pick a sample of students, some past students, maybe some current students, future we cannot. So the sample consists of some past students, some current students, and you take the values of X, the scores of students on those samples. So in the sample, let's say you select 50 students, you have their scores. What you do is you take the average of those 50 values and you have your estimate for mu. That's the whole story of sampling. Now, my question is, suppose you pick a sample, you calculate the value of sample mean, and it comes out to be X bar 1. Now, my question is, if you pick another sample from the same population, you pick another sample from the same population. Now you pick another sample from same population. and calculate X bar. And call it X bar 2. Now the question is, will X bar 2 be different from X bar 1? Can X bar 2 be different from X bar 1? That's the right question.
Yes.
Yes, X bar 2 can be different from X bar 1. So we just established, if you pick another third sample and you calculate X bar 3, keep doing this. You pick another sample, there is X bar 1, there is X bar 2, and you keep doing this. We just established that X bar will keep changing from one sample to another sample. X bar will keep changing from sample to sample. Number one. Second question. If I tell you that I picked 50 students and the CGPA I estimated, the average score that I estimated for 319 from this bunch of 50 students was 2 point, let's say no, in terms of score, let's say it was 68. Let us say it was 68. Now you pick the second sample of 50 students, same number of students, 50 students. Before calculating the average, can you, before asking the students what were your score, can you tell me what will be the value of X bar 2? I told you the value of X bar 1 is 68. Can you tell me the value of X bar 2?
We have to calculate it.
You have to calculate. Can you predict based on 68? Can you predict what will be the value of X bar 2, the second mean?
Around 68.
Around 68, but you cannot tell me the exact value of X bar 2. If I tell you that X bar 2, let us say it was 64. Can you tell me what will be X bar 3?
No.
So it is changing. Number one, it is changing from sample to sample. Number two, it is changing unpredictably. You cannot predict based on the previous information. You cannot predict the next value. So we just established two properties of X bar. One of them is that it changes from sample to sample. And second property is that it changes unpredictably. And these two properties are the properties of what? Look at this. Something that changes and something that changes unpredictably, that something is called a random variable. So we just said that like X is a random variable, X bar is also a random variable because it changes from one sample to another sample and it changes unpredictably. This proves it has a variation from one sample to another sample. If you are talking within one sample, X bar is a fixed value. But when you talk about across samples, X bar is a random variable. We just said that every random variable, once you establish the result that X bar is a random variable, then what did you say? You said every random variable has a probability distribution. That's the natural question. That's the next question. If X bar is a random variable, what is the distribution of X bar? So X bar is a random variable. This implies X bar has a probability distribution. And to differentiate it from the probability distribution of X, like we are calling this one as the probability distribution of X, the population is defined by a model called probability distribution of X. To differentiate it from that probability distribution, we give it a different name. We call it a sampling distribution. So the sampling distribution of X bar is what it is, the probability distribution of X bar. It's just a different name, just to differentiate between the probability distribution of X here. This population is modeled by f of X. This is called probability distribution of X. Whereas this X bar also has a probability distribution. This one is called sampling distribution. So I'm trying to differentiate it from that f of X. This whatever this probability distribution, whether it will be well known or not well known, this probability distribution we'll call it sampling distribution. We'll call it something different from f of X. So now the question is, what is the sampling distribution of X bar? The answer goes back from where X bar is coming. Where is X bar coming from? Look at this. X bar is equal to summation X over N. That means it is coming from the sampled values. And where is the sample coming from? The sample is coming from the population. And where is the population coming from? The population is coming from this model, denoted by small f of X. So all in all, we said that the sampling distribution ultimately will depend upon the original parent distribution of X. Because indirectly, this X bar is coming from that parent distribution. So the sampling distribution of X bar, it depends upon the probability distribution of X, which is denoted by small f of X. Now, what is the most common probability distribution in the real world?
From the special distributions or
from the special distributions, which one is the most common distribution that you see in all the engineering phenomena?
Normal distribution.
The normal distribution. So we study the most common type. We study if X has a normal distribution, what will be the distribution of X bar? So now I'm trying to differentiate the distribution of X into two parts, one where X is normal, one where X is not normal, and I'll cover all the non-normal distributions in one case. So now I'm going to talk about the distribution, sampling distribution of X bar that is depending upon the probability distribution of X. So we got probability distribution of X, may be normal, maybe not normal. All other than normal, whether it's binomial, whether it's exponential, whether it's variable, whether it's not well known, all of them, they will be covered here in not normal. So when X has a normal distribution, you will denote it by x following a normal distribution with mean mu and variance sigma square. In that case, what will be the distribution of x bar? X bar will also be normal with the same mean but a different variance. With the same mean but a different and smaller variance. Secondly, if x bar is not normal, if x bar is not normal and I say x bar follows any distribution other than normal, the mean is mu and variance is sigma square, and this f is something other than normal. If x bar is not normal, and just to write it, if x is normal, x bar will be exactly normal, and if x bar is if x is not normal, x bar will be approximately normal. So look at this whole diagram. Ahmad Ismail, your voice is very low.
Small n here, is it the sample size?
Small n is the sample size. So you just established a result. You said that because x bar, the distribution of x bar depends upon the parent distribution of x. So we got two situations. One where x is, we have the information that x is normal. And if x is normal, x bar will be exactly normal. And one situation where we either don't have the distribution of x, or we have the distribution of x, but it is not normal. It is like exponential, variable, beta, gamma, whatever distributions. So if x is not normal or unknown, in that case, you will say x bar almost follows, approximately follows a normal distribution if n is large. If n is large. And this whole thing that says that when x has a non-normal distribution, x bar approximately follows a normal distribution when n is large. This whole thing is called central limit theorem. So central limit theorem establishes a result that even if x is not normal, your x bar will be approximately normal if n is large. And now Muhammad Faris has a question, and I guess the question is how large? Is it? Muhammad Faris, please go ahead.
Yes, it is about the n is large.
So the question here is how large? And the results show that if n is greater than or equal to 30, the approximate distribution of x bar is very close to normal. How large? N should be more than or equal to 30 will give you fairly normal results, very close to normal. So in your exams, you will keep this 30 as a cutoff point. As long as your n is more than or equal to 30, you can say that the distribution of x bar is approximately normal, regardless of what was the distribution of x. Nawaf Ali.
Doctor, is there an upper limit?
And yeah, and any open limit. What do you mean by open limit?
An upper limit.
No, there is no upper limit. The bigger the better.
Okay.
Bigger the better. As you keep increasing the sample size, the distribution of X bar will keep getting closer and closer and closer to the normal. So that is called your central limit theorem. Now let's talk about exam point of view. In exam, we can give you 2 or 3 types of questions from the central limit theorem. Number 1, we can tell you that X follow a normal distribution, and we ask you that we took samples of size whatever, 29 or 30 or 50 or whatever. Find the probability that X bar is bigger than this, smaller than this, whatever. So if X is normal, your X bar will be exactly normal. You can find those probabilities exactly. The second type of question we can give you is that we say X has an unknown distribution, or we can tell you that X has a distribution that is other than normal, for example, exponential or variable or uniform. And we tell you that find the probability of X bar being greater than 10. So for that, you need the mean and variance of X. You need the mean and variance of X. From there, you can identify the approximate distribution of X bar that will be normal with mean mu that is same as the mean of X and variance sigma square over n, which is the variance of X divided by n. And then you can convert it to Z and find the probability. And how will you convert this variable X bar to Z? The conversion is Z equals X bar minus its mean, which is the same as the mean of X, divided by its standard deviation, which is the square root of sigma square over n, that is sigma over square root of n. This is how you will convert X bar into Z. And then what you do usually is exactly what you will do. You will go to the Z table and look for greater than, less than, whatever probability is required. Let us have a question. And before I have a question, if you have any queries, go ahead and ask it. And this Z is applicable from both sides, because both sides have the same normal distribution, and the only difference is if you are coming from the left side, it will be exactly normal. If it's you are coming from the right side, it will be approximately normal. Muhammad Faris, you have a question, and question is probably if X is not normal and n is smaller than 30, what will we do? Is it?
Yes, exactly.
Okay, now this question, the answer is that if n is smaller than 30, you can't do anything. You will still use the normal distribution, but you will say that the approximation is bad.
Yes, I understand.
The approximation is good as long as n is greater than or equal to 30. If n is smaller and you have X either non-normal or you don't know the distribution of X, you will say that this is the approximate probability, but the approximation is poor. So let us have a question. The question says, let us say that there is a certain machine that produces electrical resistors. Let me copy this question from the file. Okay, this question says that a certain machine makes electrical resistors having the resistance which is normally distributed. So X is your resistance. And the question says X is normally distributed with the mean 40 and the standard deviation is 2. So the variance is 2 square. Now in question number, let us say 1, I say if I select a sample of, for example, 36 resistors, and keep in mind here the distribution of X is given. It is given as normal. Look at the question. A certain machine makes electrical resistors which are normally distributed, having a mean resistance of 40 and standard deviation of 2. So the distribution of X is known as normal. You are coming from the left side here. Your answers will be exact. Okay, part 1 says if a random sample of 36 resistors is selected. Now keep in mind this is your N, 36 resistors. This is your N. What is the probability? What is the probability that the sample mean resistance, X bar will be between 39.4 and 40.3? That is your question. And when I write that X has a normal distribution with mean 40 and standard deviation 2, and I write that probability of X bar between this and this is required, this is more than 50% of the solution. Getting to extract the information from the question and getting to know what is required, that is more than 50% of the solution. You're almost done. Now it's just a matter of going to the formula sheet, looking for the formula of Z and converting it to Z and going to the table. So let us convert to Z. This will be probability of 39.4 minus mu is 40 divided by sigma is 2 divided by square root of 36. X bar minus mu sigma over square root of n. 40.3 minus 40 divided by 2 over square root of 36. So this will be simply the probability of Z between minus 1.8 and 0.9. Keep in mind, if these two numbers are having more than 2 decimals, you will round them to 2 decimals. Because the Z table, when you go to the Z table, it has Z values rounded up to 2 decimal points. Only 2 decimals are available. So if these values in this question, luckily, they are up to 1 decimal, because I chose the two values 40.3 and 39.4. They don't go up to many decimals. But if you have an exam question where the values of Z are more than 2 decimals, you will round them to 2 decimals. And this can be written as probability of Z less than 0.9 minus probability of Z less than minus 1.8. So you will go to the Z table, and I'm not going to the Z table here. You will simply go to the Z table and look for these probabilities. The bigger one is 0.8159 and minus 1.8. The corresponding probability is 0.0359. And your final answer is 0.78. Any questions from this part 1? Naif Thami.
Doctor, we will use the same table in chapter 4, right?
Exactly. Z has the same distribution. When you convert to Z, Z is the standard normal. Any other question?
Yeah, doctor.
Okay, second part, let us say, it says Find the 95th percentile of X bar. Find 95th percentile of the sample mean resistance of random samples of size 36. So you need to find the 95th percentile of X bar. 95th percentile of X bar. That is, you need A such that probability of X bar less than A is 0.95. So again, you will convert to Z, that is X bar minus mu divided by sigma over root of n less than A minus 40 divided by 2 over square root of 36. This is 0.95. So probability of Z less than something is 0.95. This is from the question. Now you will go to the table, and from the table you will obtain this. Probability of Z less than 1.645. This is 0.95. Now you will equate the two of them and you will get A minus 40 divided by 2 over 6 is 1.645. So A is 40.5483. This is the 95th percentile of X bar. Any question?
Doctor,
Yes.
the black, how you get it?
In the black, I go to the Z table and look for 0.95 inside the table. And let me try and find a Z table that I have pasted in one of the previous files. Here is your Z table. I look for 0.95 inside the table. And when I look for 0.95 inside the table, my answer is at the edges. So look what I highlight. Can you see the two values I just highlighted?
Yes.
So 0.95 is in the center of these two. So my corresponding value is in between 1.64 and 1.65.
Okay, thank you. Now I understand.
Any other question? Third part. What should be the sample size such that the probability of mean resistance being greater than 40.5483 is 5%? It's the same question, but here I'm giving you the percentile and asking you for the sample size. Here the sample size 36 was given and percentile was required. Now look here how you will solve this question. In this question, it is given that what should be the sample size n is required such that the probability of sample mean resistance being greater than 40.5483, this probability is 0.05. The first thing you will do is you will convert the greater than probability to less than. If greater than is 5%, less than will be 95%. So that's the first step you will do. X bar less than this number will be 95%. That's the first thing. Convert to less than. Once less than is done, you convert to Z. Probability of X bar minus mu over sigma over root of n less than 40.5483 minus 40 divided by 2 over square root of n. Now n is unknown. This is your first equation. Z less than 40.5483 minus 40 divided by 2 over root of n. This is 0.95. You'll get the second equation from the table and you'll get the same. Z less than 1.645 This is 0.95. You equate two of them and you will get n. 40.5483 minus 40 over 2 over root of n. This is 1.645. And from here you will solve the equation for n. And you will get n equals 36.0044. Now when you solve this equation for n, you will get the value of n in decimal. Now I have a question. Can n be 36.0044? Can you select 36.0044 values? Can you select 36.0044 resistors?
No.
No, you will round.
Integer.
You will round it. The way you round it, you will round it to a number. If it is 36.5, you'll round it to 37. If it is 36.4, you'll round it to 36. So your n is round it to n equals 36. You will round it as usual. No rounding up, no rounding down. You will round it as usual. Any question?
It's clear.
Another tough question. And you can practice with many of these questions yourself, but let me give you a tough one. Look at this question. In this question, and this is very tough. This is, I would rate it as A plus question. In this question, it says that if the random samples of size 36, this is n is given, they are taken and probability of sample mean resistance being greater than true mean resistance by at least 0.25 is 0.1. Find sigma. Now sigma is unknown. You are given that x follows normal distribution with mean 40, but sigma is unknown. Sigma is not given in the question. And they say that if the random samples of size 36, so the first piece of information is n, that is 36.
Doctor,
Yes.
repeat the question.
Can you see the question?
I can't read it.
I can't see
I
this.
cannot hear you.
I can't read it.
Because of the handwriting?
A little bit, yeah.
Yeah, I'm reading it. I'll read it again. The question says that if random sample of size 36 are taken and probability of sample mean being greater than the true mean mu by at least 0.25, that probability is 0.1. Probability of sample mean being greater than population mean is by at least 0.25. So the probability that your sample mean will be greater than population mean by more than 0.25, that probability is 0.1. How can you write it as an equation? The probability of sample mean being greater than population mean by at least 0.25. So the sample mean is greater than population mean by at least 0.25. This probability is 0.1. The equation you see in the red color, that is 70% of the solution for this question. And you're required to find sigma. That's done. That's 70% of the solution. The remaining 30% of the solution is what you convert to z. That's it. X bar minus mu divided by sigma over root of n greater than mu plus 0.25 minus mu divided by sigma over root of n. That is 0.1. So you got probability of z greater than square root of n is 36, I think. 36 square root. So you got 0.25 over sigma divided by 6. This is 0.1. You got this from question. And then you will go to the z table and you will look for, no, this is greater than probability. This is not my equation. If greater than is 0.1, less than will be what? Less than will be 0.9. This is my equation. Now I will look for 0.9000 in the table. I will look for 0.9000 in the table, and the corresponding value will be my z. So probability of z less than 1.2, let us say it's between 0.28 and 0.29. So I'll take the middle of 0.28 and 0.29. So from here you got the equation that 0.25 divided by sigma over 6, this is 1.285, and you will solve this for sigma and you will get 1.167. Similarly, I can ask you a similar question about mu. Here I hide the value of sigma. I can also hide the value of mu and ask you the similar question.
The normal, excuse me, doctor.
Yes, in the normal distribution, what?
We always look for z less than a number.
Yes, we always convert every question to less than.
Okay.
Before going into the table, for any normal distribution question, we always convert the question into less than. Whether the original question is less than or greater than or in between. In all three cases, we convert it to less than before going to the table. Another interesting part is here. Now this is where things suddenly change. What is the probability that the resistor of a resistor exceeds 41? Who can answer this question? What is required here?
The percentile.
Which percentile? Find the probability. So the probability is required, not the percentile. Percentile is the value. So the first three letters of the question tell you that probability is required. Which probability? Muhammad Faris.
The probability of percentile equal 41.
Which percentile?
41.
41 percentile?
Yes, because
what is the probability that the resistance of a resistor? What is the resistance of a resistor? The thing I highlighted in the blue color, what is that? What is the notation for this thing? Resistance.
X.
X. This is X. What is the probability that X exceeds 41? What is required?
Greater than 41.
X greater than 41. This is where the things change. And suddenly we come up with an easy question and you think it is too tough. And you start thinking about X bar, the sampling distribution, the percentiles and all that. This is a simple question from chapter 4. Probability of X greater than 41. You just have to write it equal to probability of X minus mu over sigma greater than 41 minus 40 over 2. No n, because this is a question about X, not X bar. No sample size here. So this will be probability of Z greater than 0.5, I think. and you will convert it to less than 1 minus probability of z less than 0.5, and 1 minus, you'll go for z table and look for this probability of z less than 0.5, and this probability is 0.6915, and your final answer is 0.38. 85? 185? 3085. What is it?
Yes, 3085.
Yes.
085.
Yes.
Yes, correct. Yeah, doctor.
Now, last comment about chapter 7. This is all your chapter 7. Last comment about chapter 7. What if in this whole question, where was the question? What if in this whole question, this was not there? Nothing will change. Nothing will change. All your answers will be approximate probabilities, but nothing will change. Even if here instead of normal it was given as exponential, nothing will change. Weibull, nothing will change. Central limit theorem will come into the picture and all the probabilities will be same. The only trick that can happen is that I can tell you that x has an exponential distribution with, let us say, lambda equals 3. That's the only possible thing that can happen. I can tell you that x has exponential with lambda equals 3. Find the probability that x bar is more than 3.1. So you will convert. First, you need to find the mean of x. Mu is for exponential. What is the mean? The mean is lambda. And for exponential, what is sigma square? Or let's say sigma. Sigma is the square root of lambda, I think. No, mean is 1 over lambda. And that one is 1 over square root of lambda. So you will find the mean and standard deviation from the formula sheet of exponential distribution, and then you will convert to z based on that mean and variance. Any questions? Yes, Ali Abdul Rauf.
Yes, Doctor. I didn't understand quite the above question. How did we say it is greater than 41?
Where is it?
Yes, this question.
What is the probability that the resistance is greater than 41, exceeds 41?
We said earlier that exceeds, it means that less than.
Exceeds is greater than. Exceeded by is less than.
Exceeds by, it's less than?
Yes.
Okay. I made a mistake. Thank you.
Any other question? Okay, because you're not asking any questions, go to the blackboard. Go to the blackboard and you will see class participation number 4. And for solving this class participation number 4, this is from sampling distribution concept, and you will have 2 attempts to solve this one. You solve it. If you get it wrong, solve it again. If you get it right, leave the class. The formula of z, I'm going to write it here. And the table, you can open it yourself. Turki Al-Ghamdi, you have not started the test. Turki Al-Ghamdi. Those who got the right answer, they can leave the session, and those who are not getting the right answer, you can attempt it as again. You can attempt it 2 times, you can attempt it 3 times. The test is available up to 10:30.
How many decimal, Doctor?
For the value of z, you should round up to 2 decimal points, and for the final answer of probability, you should get the answer from the table in 4 decimals.